Hey all, welcome back for exciting live session, and thank you for waiting for a very long time. So we have our speaker. So let me introduce Anubhav Singh. So he's a co-founder at Callchimp.ai, and he's also a Google developer expert at machine learning and GCP. One second, just a second. Cool. So there were two noises going on. All right. So let me give you a brief about what we will be discussing in this particular live session. So we will go through the introduction of AI because if you look at the core space we are working on, there are lots of research project that is being developed every single day. So it's pretty native. Like in order to cope up, it's probably very difficult for any beginner to cope up with this space. So we have our expert in this particular session where he will tell us about the real-time applications that one can build the projects on. So without further ado, I'll let Anubhav take over this particular session.
Okay, thank you, Tarun, for the introduction. And before I start sharing my screen, I'd like to get to know my audience a bit. So, quick question: everyone have access to the chat here, or do I need to look at YouTube for the responses?
Yeah, they have the chat. If there is anything, I'll probably add that in the screen so that you can see that on the screen itself.
Sounds good. Okay. So I think the first question I want to know is like, which year are you guys from, right? Just mention whichever year you are studying in. If you're a graduate, do mention that as well. Um, or else, if you're yet to go to college, do mention that as well, right? So let's take 2 minutes to understand. Uh, what first year? Okay. Mm-hmm. Awesome. Awesome. Okay. A lot of first, second, and third years. I see. Final year. Okay. First
So
year
on
and
average, we have most of the people from first year, first and third years.
okay, I see a lot of excitement from them. I think these are the two times when college students are like really serious about exploring, because in your first year you are like wide-eyed and you want to explore everything, and then in the third year you are looking for something to finalize that. Okay, this is what I'm going to work on. Right. So anyway, yeah, give me a moment. I believe I understand what's happening here. So let's get started with the slideshow. And while I'm doing the slideshow, guys, just to let all of you understand how this is going to run, I'm going to ask a lot of questions. I'm going to expect a lot of answers as well. Okay, and let me quickly try to open the YouTube link as well somewhere on my system so that I can take a look at all the responses which are coming.
So probably I'll be moderating as well. If in case there is any other question, I'll be adding those to the screen.
Mhm. Yeah, great. Now I see the responses, so this is awesome. And yeah, let me start sharing my screen. How do I do that? Present, share screen, choose a tab, and this is the tab I'm going to present. Okay.
So once
Yeah.
you start sharing the screen, I can see your screen now. Like it's on the screen. Introduction to AI ML in real-time applications.
Cool. Okay, so let's get started with the session itself. And the topic which Tarun asked me to talk about was introduction to AI ML in real time applications, right? So what this essentially means is we are going to be focusing on a specific type of software. We are not going to be talking about general software, which a lot of us use on a daily basis. Rather, we are going to talk about all the applications which work in real time, and we are probably going to take a look at the different kind of technologies which are used to enable such software. At the same time, we are also going to look at the challenges of those, right? So yes, let's get started. Hi, I'm Anubhav Singh. I'm the co-founder of Callchimp.ai, GD for ML and GCP, and a bunch of other things. If you're interested in any of those, let me know. That said, I have a very specific, very simple agenda today. Uh, just 5 points on the agenda, and at the same time, I think I'll have a lot of questions for you all, and I would like to see you all participate in answering it. Right? There's someone called aspirant. Satyam is an aspirant. Okay. Yeah. Anyway, let's say hello to AI era, because I think in today's date, pretty much every company is using AI in their applications. All the software developers, they want to build something with AI. So I don't think I have to explain a lot to you. I think this graph tells pretty much everything that you need to know about how much AI has taken over the world in the last couple of years, and the graph is just upward, right? If you look at the interest which has been coming in from since around 2022, what happened then in 2022? We got something called ChatGPT, right? And although we did have generative AI tools before that, right? There were a bunch of models which were doing generative AI even before ChatGPT. And in fact, for anyone who has explored this particular segment, you know that the work in generative AI itself, large language models, all of these started way back. But then it got really popular with the ChatGPT coming in, and all of a sudden it became a household commodity, right? And from there you see the graph. It's just upwards and upwards, and history tells us that at some point it will plateau out, it will become flat, but then for now it's growing. And I think for all of you who are even in your first year or the third years, I think this is a great time for you to explore um, building AI software. But then again, yes, we are focusing on something called real-time software today. And there are actually two types of real-time software, right? There's something called hard real-time, which means if you screw up, you are going to possibly incur a lot of loss, or else maybe even lead to death at times, right? Think about banking systems in which they have to recognize, let's say, credit card based frauds in real time, right? Fraudulent transactions. For those of you who have probably done a very unique kind of transaction, maybe you would have got a call from the bank saying, hey, just confirming, was this a good transaction which you did, or was this um, something which is dubious, right? So Sneha says, how can we combine finance and AI, like investment related, analytics related? Okay, I think that's not a topic for me today, unfortunately. Combining AI with finance is a different thing, and real-time software is a totally different thing. Uh, Although they do go together, but then I'm not going to be talking about that. Obviously, the next part of real-time software is soft real time, right? Soft real time is something which is similar to what's going on right now in this Google Meet, I believe. We are using StreamYard, so I'm speaking, you're listening to me. It's okay if I go blank for a while. It's okay if the stream pauses, if your chat is not coming to me in real time. That is also fine. I think we are already having some 5-10 seconds lag. All of that is totally fine, right? And if you see the hard real time, some examples of hard real time, right? Navigation systems. For those of you who have heard about Tesla, they need to be on their toes, on their A game for real time AI, right? It's happening on the device, it's happening right there. And if they make even the smallest mistake, it might lead to accidents, crashes, stuff like that. Um, Drug recommendation software could be real time. I don't think so. I mean, drug recommendation, let's say, you don't really need to have your medicines in real time, as in you go to the doctor and he keeps subscribing you medicines one after the other, and you just keep having them. This is not how it works, right? They take some time, decide on the medicine, give you the right medicine, and then that is when you take it slowly, probably once in 24 hours. So not really a real time software solution or a problem for real time, but these are, right? If you think about the machinery in manufacturing, right? The hardware, the robotics out there, which are a part of manufacturing. If these robots miss a step or they are like late to their step by even half a second, the output could be drastically bad, right? So think about one of the soft drinks factories, right? These soft drink factories, they involve a lot of these robots, and maybe there is a robot which is supposed to put in the let's say the sugar component into the soft drink, and if it does it for 1 second extra, when we are talking about that amount of bulk of processing, the sugar will be really high, and that drink might become undrinkable, right? So it has to be very on time. Similarly, Google Maps. For those of you who love driving around or traveling around, you know that how difficult it is to navigate if your Google Maps is slow, right? They need to be on point all the time. If you even turn on the road slightly, you expect that the map should turn with you so that you are able to understand which way I'm going, right? If this does not happen, I think we have all seen a lot of memes around, Google Maps leading people to wrong places. So yeah, it needs to be real time. And then obviously the last one, which I've shown, is probably one of the most critical uses of real time software, in which someone mentioned it, right? Uh, it's an iron dome defense, which we call it, in which software is used to understand the trajectory going to be taken by missiles, and then you launch counter missiles which intercept them in the sky itself, and reduce the amount of damage which is going to come down on the people who are living in the area, right? So all of these are really critical. Even half of a second delay could mean a huge difference in the results, right? One time you are driving safe, and the other time you are crashed in a tree. Just half-second delay of processing will make that difference. Um, yeah, is now casting econometric variables hard real-time software application. I'm not really sure what econometric variables are. So maybe if you're talking about the finance markets, maybe that is what. Obviously, if you are using AI or any kind of software to place financial bets, as in putting money in the stock market or stuff, yes, you have to make it sure that it's like pretty real time. If not, then you could lose amount of money. It may be small, it may be large, depends on how much you're investing. But then these are say examples of soft real time, in which, first of all, the social media, all the social media we use, although we do feel like it should be real time, we always cry about, let's say some video app being slow, being laggy. It's okay. It's not necessary to use the world's computing resources to make it faster, right? It's okay if your messages get delivered with 1 second delay. It's obviously there can be circumstances and situations in which it can be disastrous, but then most of the time social media is not considered as hard real time. And then obviously your financial transactions which are like done on the ATM, you might think like this is something which should be real time, but actually not, right? Because when you are interacting with physical ATM machines, the expectation is that whatever transactions you are doing at that ATM, you're also not doing the same transactions or similar transactions on another ATM at any point. So it's okay for the records to get reflected slightly later. Some of you might have seen this with some of the bank apps, that after you have done the transaction, right after you have done the transaction, it does not get updated, right? It probably takes like 1 minute or 2 minutes to get updated, and that's totally fine because on the back end they have already reduced that amount and locked your amount there, right? And then finally, yes, gaming. A lot of real-time gaming happening in the world. I believe people who are into gaming, you might recognize the picture. And while to you it might look like it's really important for it to be real time, it's actually not. I mean, in the face of a global catastrophe which requires real time response, if you lose a game, no one cares. So eventually, yeah, gaming. Yes, definitely. I mean, you can think it's hard real time, but there will obviously be a lot of debate around it from people like me who like, I know, we are okay with losing a few games here and there. Uh, Content recommendations, definitely soft real time, right? If you go to YouTube and if you start watching videos of a certain category, certain genre, um, it's okay for your recommendations to get updated maybe 20 minutes later, maybe 30 minutes later, maybe the next day. It does not really matter if it's getting updated slightly later. You don't really want immediate updates in your recommendation. So yes, content recommendation definitely is soft real time. um, there's even a question whether it should be real time, right? If it's not real time, I'm okay with it. Obviously, a lot of recommendation engines try to work in real time because that is when they will be able to increase your engagement with let's say on Amazon, they try to recommend you products right after you have started seeing them. They start showing you more related products so that you end up buying before you close that shopping session. And that is just something which they do for increasing destination recommendation. In MMT is hard or soft real time. It's definitely soft real time. It's even a question whether it should be real time, right? I mean, if I go and search for, let's say, Bali, Indonesia, it's totally fine if the next day they start suggesting me Jakarta as well, right? Jakarta is the capital of Indonesia. So I'm totally fine with that, even if it's not real time. Um, but if it does do the recommendation, it will never be hard real time because it's totally fine if I do not get the recommendation right away. I get it after 2 minutes, after 5 minutes. It's totally fine, right? So yes, it never comes into hard real time. Anyway, let's take a look at some of the problems, right? See, real-time software itself is so intensive, right? If you saw the previous examples, you understand that all these softwares themselves are like really intensive to work with, like you know driverless navigation of cars. That is so much intensive. There has to be a lot of processing to go around. Like, it's looking at a camera in the front, it's probably looking at cameras on the sides, there are some sensors, looking at the road, looking at the sky, could be anything, right? So it's so much processing intensive, and it has all to happen on real time. And for those of us who have worked with any kind of AI systems and use any kind of AI applications, we know that AI, making it fast is like a really difficult thing, because there's a lot of calculation going in, right? Even the smallest neural network will probably have at least 20, 30 steps of calculations in between. And that is why it's like really difficult to do that amount of computation in real time. And putting it in real time solution, AI in real time software, it comes with a few issues, right? First of all, I think scalability is one of the biggest issues, right? If you have the best GPUs, if you have the best hardware, you can probably run inference on that particular hardware at a decent speed. Let's say maybe half a second amount of speed. But then if you have to do it with like 10 concurrent requests, you will see that the software dies much faster, right? It's really not possible to do that. And obviously, to replicate that in terms of increasing the hardware, that is like really difficult, right? You cannot just keep purchasing GPUs. You are not Google, or you are not OpenAI. You cannot just simply keep purchasing more hardware to increase the scalability. At the same time, reliability is a challenge, right? Ensuring that it works everywhere all the time. This is really difficult because let's say if you have, just think about a Tesla car. They are doing driverless navigation, and they need to make sure that whatever AI they are running is always correct. And that is like really, really difficult, because it's like really easy to fool some of the AI systems. You might have seen a lot of memes around AI recognizing things wrongly. For example, a cookie gets recognized as a cat. It's like really easy for that to happen. And if that happens in a real-time software system, which is if God forbid it's a real-time software which is like hard real-time, you might run into huge problems, right? Yeah, Maud's sense of humor, where, okay, no clue where the humor is supposed to be, but anyway, we are discussing the problems. right? So security challenge, right? Now I'll tell you where one of the biggest problems with security comes in real time software. In real time software, you are actually trying to cut down the number of steps from input to output, right? Maybe you are using real time software to activate the airbags in a car. So to do that, you have to detect the collision very quickly, and then from the collision being detected to airbags being activated, the number of steps in between should be very, very less. And in between, if you pose the questions of, let's say, the security part, in which you ask the question, hey, whatever systems you are going to use to do this, it should at no point breach my privacy by looking at the passenger, right? It should not record the face of the passenger, it should not record what the passenger is doing with his or her body. If you start posing questions like this, it becomes really difficult, because then you have less number of sensors available, then you have less amount of data available to make decisions, and it could be leading to delays, or maybe even potentially leading to the airbags not being deployed at all, and that becomes a real challenge. So security is just additional layer, and if you add more layers in between in real time software, you could face drastic issues. The accuracy challenge as well, right? I think it's a well-known formula that if you want to make something faster, you can choose to reduce its accuracy, right? Think about all the fuzzy algorithms that we learn. Think about all the approximation algorithms that we learn, right? All of them work on the same principle that you're okay to trade off accuracy for speed. And this, while this has given the world a lot of good results, um, at the same time, when you're thinking about hard real time problems, accuracy might be like super, super important, because if it's not accurate, then there are possibilities that whatever reaction is done by the AI in against of whatever input it got with lesser accuracy in output, um, that might damage a lot of things. Let's say you're driving on a road, and the machine thinks that it's an empty road, and all of a sudden an animal passes by, maybe a dog which is like just crossing the road. I think it has happened to a lot of us, that while you are driving your car or bike, suddenly a dog crosses the path, or a cat crosses the path. If it in the speed at which it is going, that when you're driving this way, you're driving on the road and someone crosses horizontally, the number of even the visual frames which are available to you are really less. And depending on the shutter speed of the camera which is being used, that dog might not look like a dog. The dog might look like something which is slightly just a blur. And if it does not get recognized as something which could probably get hit and get damaged, then the car will never slow down, never stop, and that might result in accident, right? So accuracy is definitely a huge problem for real-time AI, and yeah, God forbid you don't have to pay for it heavily, right? Anyway, let's talk about some solutions. And in talking about these solutions, I'll mainly be talking about the products which are related to these solutions. But then at the same time, I'll also talk about the products, right? I'll simply mention the products. You can Google them up. You can read more about them. You can think about integrating them onto your systems. But I'll tell you how they solve things, right? So scalability, I think the first way to solve it is through distributed computing platforms. And the three tools I'm mentioning here are Kafka, Flink, and Spark. All of them are maintained by Apache Software Foundation, and all of them are used for uh, doing the computation. Whatever computational complexity you have, they distribute it to multiple platforms. For those of you who know these terms, you understand that. But then for those of you who do not, let me just try explaining them very shortly. Kafka is a streaming software, right? So it allows you to stream data in high volumes over multiple endpoints, or could be getting data streaming in from multiple endpoints. And Kafka is probably the one which is used by almost all the OTT platforms that you use, right? Besides that, Flink is yeah. So Flink is basically a real-time software, and what exactly is it used for? It is used for uh, when you want to process data which is coming in maybe from a real-time sensor, or maybe coming in from any source which generates a lot of real-time events, you want to process them with lowest possible latency. That is when you use Apache Flink. So it allows a framework for doing that with minimal amount of time. And similarly, Apache Spark, we know it is for doing distributed processing over data which is stored on multiple platforms. So think about a very huge amount of data, let's say 100 or 200 TB of data split over multiple devices, multiple storage disks of let's say 1 TB capacity. And if you want to process the data in overall, let's say we have financial transactions records which are split over 100 such storage devices, and we want to get the average transaction value, right? So it has to compute over all the different disks. That is when you use something like PySpark, which allows for distributed storage processing in a faster way. And then load balancing, obviously, yes, people, yeah. Load balancing, people might be very much aware of Nginx. Nginx is a soft, popular server software, which obviously kind of came as a replacement to Apache. So Nginx allows a lot of low uh, resource requirement load balancing, right? You can probably run Nginx on the smallest possible computers. It runs perfectly on Raspberry Pi. That is my experience. And you could also use something as low as 512 MB is very okay with Nginx. And then there's the HA proxy. HA proxy is a specialized software which is for high availability proxy, right? So in case your load balancing, goes down somewhere, HA proxy takes care of making it available all the time, having a lot of redundancy on it, right? And then obviously the reliability part, right? Reliability basically means that your API or your business logic, it keeps responding all the time. So that is what reliability does. And the first thing you need for reliability is monitoring, right? You need to always keep looking at what is the status of my application or an API. Is it responding now? Is it not responding now? So to do all of these, Prometheus is a great tool. And you take Prometheus, you take Loki, you connect them with Grafana, and you can really build a very nice dashboards out of it. So think about any of the status pages that you see, right? Let me actually show you an example of this. Uh, Maybe I can do that. Give me a minute.
Yeah, until then, we have a question like human
Okay.
errors while using technology are often set aside as necessary evil for greater benefit the technology providers. However, shouldn't there be any acceptable amount of error for AI too?
Human errors while using technology are often set aside as necessary evil for the greater benefit of the technology provides. However, shouldn't there be acceptable amount of error for AI too? I think we are already accepting a lot of errors, man. You just need to look at machine learning itself. It's never 100%. It's already at like 95%, 90%, somewhere down to like 85% even. Um so I think we are already taking a lot of errors from them in real-time software, specifically the ones which are critical and possibly fatal. You would not want mistakes from anyone there, right? Be it human, be it AI. The error is simply not acceptable because try explaining that to people who are not there anymore, right? That hey, this particular error, it was probably acceptable. Try saying it to them. I think you need to think about when to accept it, when to not. And in some use cases it is simply not acceptable at any point of time. I think a lot of errors because of software, because of humans, have happened in the world of technology. People have at times faced problems due to it. And I mean, one of the biggest examples I think which I can give you is there was this airline in the US, and someone asked its chatbot whether they were providing some sort of free tickets or something, and it responded with yes, and then that person claimed for it, right? And they went to court, and eventually the airline had to give them free tickets. So that was definitely an AI error, and someone had to pay for it. But I think it is acceptable, right? It's not like they're going to shut down that AI and not use it again. Uh, so definitely, yes, there we have an example of people accepting AI error. And I think a lot of companies, when they're building AI solutions, for those of who understand it, they know that it's not magic. It's just working on data which is coming in, that is used to produce the insights, whatever insights we are producing, and it can be wrong at times. It's just a trade-off between the cost that you will incur when you are wrong to the amount of income you will make when it is right. So I think a lot of tolerance is obviously there already. Yes, that said, I'll quickly show you an example of how you can use something like Grafana for monitoring. And let me share my screen, entire screen. There we go. So just giving an example of using Grafana. So here's a Grafana dashboard. This is something which I use for my own company, and I created a monitor for myself. And you can create something like this, right? You can create monitors like this. Right now it's all no data because today is Sunday. Today we are not placing calls. But on other days you can actually see a lot of different kind of let me go to, let's say, production, and you see a lot of these monitors which are being built. These monitors are not being built by this particular software. No, this software is simply using Loki and Prometheus to take input of data. And if you see, there's something called data sources, and inside data sources you can define a lot of data sources for bringing in data from different sources. And once that is done, that is when you go to explore and you start creating, choose your data source, and based on that you can start selecting, let's say, the production environment or the staging environment. And just by using some UI tools for building the queries, you can build the queries, and those queries can then be used to create dashboards like this which allow you to monitor. And at the same time there's also a lot of alerting available, and inside alerting you can see the rules are defined. And for example, there's one which is like log volume below threshold, and if your volume is down, you can choose to take some actions based on webhooks which get fired, or else you can choose to import that particular information to something like Google Chat. So if you see, we have a system notifications here, and we do keep a track of all different kind of systems. There's a lot of complaints about OpenAI health check, and based on this you can decide how to act, right? For example, whenever OpenAI goes down, we can choose to shift to another AI provider, because whatever software we run at Callchimp.ai, all of it has to be real time, right? Obviously, it's not a hard real time; it's just a soft real time that we do. But at the same time, when you are talking to someone on the call, you don't want a lot of gaps there. So yes, we need to make sure that all our software system is real time. Cool. That said, I think let me go back to presenting my slide, and okay, here we are. So yes, you can use Prometheus and stack it along with a lot of solutions like Loki, Grafana. There's also the Elk stack, in which you have Elasticsearch, Logstash, and Kibana. There's obviously a number of more services which are available, and both of these you can use for monitoring all the time. Um, Personally, Grafana fan, but then obviously Elasticsearch is a proven product. At the same time, when you are monitoring things, then you need to be able to take some actions, right? For example, you are monitoring that, hey, my server has crashed. Now the question is, what do you do about it, right? Your server has crashed, yes. How do you solve it? One of the solutions is definitely Kubernetes. Kubernetes allows you to do container orchestration, right? What that means, let's think about your server, whatever software your server is running, as one container, right? Whatever solutions you have built, maybe a computer vision API, could be whatever tools you are running, maybe batch processing, may not be real time at all. Whatever you are running, let's put them inside a single capsule, make them isolated. We call it a container. You could use Docker to wrap it. You could use some other technology. There's a bunch of container technologies out there. You can use any of them, and then you can use Kubernetes to automatically scale up, scale down those number of containers that you're running. You could choose to run 0 containers, you could choose to run one, you could choose to run 1,000. Kubernetes can do that for you very easily. So whenever you are monitoring your server, if your server goes down, you can immediately use Kubernetes to spin up another instance. In fact, you can choose to spin up multiple instances, right? And then obviously there's again the mention of Kafka, because Kafka allows you to stream in all the monitoring, and based on that, you can choose to scale up, scale down your systems. That said, I think security is a great parameter that we need to look at. And data encryption, I think no brainer here for anyone who has worked with software. TLS, SSL, really important. Encrypt your data on both ends while you are sending and passing them around. And advanced encryption standard, AES, is just one of the ways of encrypting data. Then there's authentication and authorization. Whatever software you're building, make sure it has the correct layer of security on it. Think about sitting in a Tesla car which is hijacked, and I don't think anyone will like, that you wanted to go to the airport, but you are being taken to your destination just by the road transport. I think no one will like that. And then obviously the intrusion detection system. Snort is a very popular one. So Snort uses AI to detect whether any system has been intruded by the malicious actor. So you can use intrusion detection systems specifically built with AI to detect such intrusions. Right? Not all intrusions are detected by patterns. So intrusion detection systems by themselves, they are mostly of the rule-based ideas, or else the AI-based ideas. There are obviously other types as well, and AI-based ideas is actually getting really popular these days. And finally, yes, for accuracy, what you can do, you can obviously use any of the optimization techniques for AI, as in, you could choose to strip down the number of layers which you have, or else you could, in today's date, quantization is like really famous. You reduce the number of possible range of data that you work with, and then if you could build for stuff like TensorFlow Lite, then it's really easy to run it on edge devices, right? So whatever you are developing, if you convert it to much more optimized binary runtimes, you can run them probably on a single Android device or maybe on a Raspberry Pi. You could also choose to put it in a container, and these containers will be like really small, and they can run pretty much everywhere. People who work with AI-based software, especially if you're working with LLMs in today's date, you know that you could always have LLMs which are like smaller, and they had a smaller training data, and they can probably produce a limited amount of responses. But then the question begs, right? Do you really need the full scale of a huge LLM all the time? Maybe not, right? Sometimes you can choose to have smaller LLMs do the same task, which could have been done by someone else, like a larger model, or else sometimes you could choose to have specialized models as well, right? I'll give you an example. When you're doing real-time calling, the way we do, we need to do sentiment analysis a lot, right? We need to understand what sentiment the customer is going through while we are probably pitching a product, or else we are just trying to establish hi, hello. Sometimes people are just really angry while they pick up the phone. So we need to understand whether which route to take. Do we become very cheery with them? Are we going to start with sorry to disturb you? Stuff like that, right? So we need to do sentiment analysis a lot. And turns out if you're using an LLM API to do sentiment analysis, it will probably get you the answer in, let's say, the smallest being somewhere around 500 to 600 milliseconds if you're doing an API call. But if you're using a sentiment analysis model in-house, running on a CPU, you can probably get the same answer in like 40 milliseconds, and without the cost of running, like calling that API. And this should tell you that use specialized models wherever it's necessary. Do not use just an LLM for everything. Um, then obviously you can think about that data augmentation and pre-processing techniques, right? What these can do for you. Uh, so think about allumations as you know, increasing the amount of your data set if you want to enhance the training data set, or maybe you can do a lot of pre-processing on your data set, which allows you to produce the responses faster. Just to give you an example, think about the MNIST data set, right? For anyone who has tried out computer vision, I think MNIST is probably always the first introduction that we do. MNIST or iris data set. For image data sets is the MNIST one. For uh, yeah, computer vision is MNIST, not IRIS. Sorry, IRIS is for tabular data. Yes. So for anyone who has worked with the MNIST data set, you know that it's a data set for digit recognition, right? Handwritten digits are getting recognized, and at the simplest, it's like zero to 9. Think about if your data set was created by taking photos of digits on a postcard. You could choose to have larger images as well, you could choose to have smaller images as well. The question here is, what is the correct size of the image which will allow you to produce the final output, which is recognizing the handwritten digits with the least amount of calculations possible, right? And instead of using a 1024 by 1024, you could do it by something as small as 256 by 256. And that is one way of reducing the amount of effort it will take both to train that data set and to do inference on that data set, right? So whatever in future, whatever recognizing you have to do of handwritten digits, whatever image is being fed in before feeding it in, you cut it down, you crop it down, you make it smaller to 256 by 256 image, and that's way more faster. And then obviously I need to mention here the NLTK. And you might be wondering, like in the age of LLMs, why am I mentioning NLTK? The reason being classical natural language processing, that will always be much more faster than the neural ones, right? I say faster, I don't say more accurate, I don't say more magical, I just say faster, right? For example, uh, if you want to do the prediction of what next word the user might be typing, right? You can definitely use AI to do that based on whatever has been typed so far. Whatever the user is typing, you can suggest him the next possible 4 or 5 characters. Very easy, can be done with neural networks, with LLMs, whatever you want to. But then I think classical NLP has a very great solution to it, right? Maybe not encompassing everything possible, maybe sometimes wrong, but yes, it does have a solution. And sometimes, so when you are dealing with like real time situations like that, uh, slight amount of accuracy reduction will not hurt you a lot, right? So you can always look at the NLTK for a lot of replacements of things that you might be already doing with LLMs. Just take a look at NLTK, try to find out if something already done can replace your use of an LLM or any other larger model, and try to use that. So that said, I think from my speaking perspective, this is all. Um, Now I will like to take some questions.
Yeah. So how do we learn to integrate and use these services? Do this comes under the realm of MLOps?
Um Not really. I mean, it does not all fall under MLOps. All the things I discussed, right? For example, distributed computing platforms. Yes, it does fall into the realm of MLOps, but not all of them, because the Spark itself comes under the ambit of data science, right? In which you are trying to gain insights from a large amount of data. Similarly, like HA proxy is definitely something which comes under MLOps, but at the same time, tools like Kubernetes or Kafka or even like Prometheus and Grafana, uh, they do not necessarily come under MLOps. They are more like DevOps things, right? Um, you would think about MLOps when you are designing the whole pipeline of from data ingestion to output of the model, and how that ingestion data keeps on getting updated and how the model keeps getting retrained and stuff like that, right? So that is where you put in MLOps. Um, yeah. Is it required for beginner with all these software for reliability, accuracy, or these current applications over the world? Uh, yeah, I mean, for someone who is starting with software development, um, or even like something as simple as you are starting out with things like this, right? The reliability and all of these things. Uh, I won't say you really have to start out with these tools. These tools are like really professional. These tools are very enterprise grade solutions, and you could choose to not go with them at the very starting. For example, before you start working with Kubernetes at a production level, you can probably search, you can get started with something as simple as Docker, and then write your own manual Docker scripts for deploying a bunch of these in one go, and probably replicating them, reducing the number of replications. You can use Minikube if you wanted to. Minikube allows you to use Kubernetes on a single system, right? You don't need multiple systems to use Minikube, and I think you should be good. So yes, these are like whatever tools I mentioned. All of them are like really enterprise grade solutions. You will probably not have to worry about automating them until you go into something like that. Complete roadmap for data science. I mean, yeah, I'll probably try to answer this by going to a website called DataCamp. Personally, I did learn a lot of things from DataCamp itself. And while DataCamp is paid, yes, it is paid. I think what you can do is you can take a look at all the courses here, and you can just take a look at all the topics and what kind of stuff they are discussing in these, and you can choose to just quickly then Google them yourself and probably find some YouTube videos, find some tutorials, and learn these things, right? So yeah, it's totally up to you. I think they have a great assortment, especially in the career and skill tracks. So you can choose a career track of, let's say, data scientist with Python, and you will get which courses they are covering in this, and you can simply just look up all the curriculum of these particular courses, and you can find them on different websites. Datacamp is paid. I'm not saying you should not try out Datacamp, but then if you can get it for free, why not, right? So you can search around these and study that. Okay. How to learn AI to solve real world problems. I mean, you will solve real world problems first of all by working with real world problems, right? A lot of us do not have that opportunity while we are at college. But then, yes, you can always look at problems around you and try to solve them. I think once you start solving a problem, the learning comes by itself. And if you ask anyone who is into AI, even Tarun here, right? If you ask any of us, like, how do you learn to solve something? The idea is solve it, right? First, you will come up with a very bad solution. Then eventually you will learn to keep optimizing it, and then you will probably finally reach a solution which is state of the art at that point of time. In future, it might have another state of the art.
Yeah, so probably even I'll add a few sentences. Like, in order to solve real world problems, first you can pick any industry that you're interested in. Like, it can be education, finance, or manufacturing, retail. So once you pick any industry, next thing is now you have the freedom of using Perplexity, freedom of using GPT. You just pick an industry, use a chat model, and tell them to generate 10 case studies. So once you have certain case studies, you have the understanding of what kind of projects you can build. Then pick one of the case studies from the response that is generated, and then again ask ChatGPT, hey, can you generate me 10 different use cases so that I can work on it? And once you get the use cases, you can eventually get the problem statements as well. So it's like pick a industry, generate certain case studies, pick one case study, then generate use cases and problem statements. So once you have problem statement, you can pick any framework that you are comfortable with and start building. So that's one approach that anyone can take. Yeah, we have one more question.
Is it possible to achieve both speed and accuracy and not trade speed for accuracy? I mean, yeah, this does not like the maths behind this, right? Let me show you a small example. For example, if I want to do something which is like I want to take a number, right? Step one, take a number. Step two, cube it. Step three, square it. Step four, divide it by 500. Step five, mod of 40. Step six, output. Right. If this is my process, I have to go through this process, right? I mean, I could choose to do a approximation of the result. I talked about this, right? Approximation algorithms. But then, if I want to do it completely accurately, I will have to go through this process, right? Uh, maybe I can combine these steps. Yes, it will be very smart probably to combine these steps, because if you divide a number by 500, it is going to leave some quotient, some remainder, and then you can just simply pick the quotient and do the mod of it over 40. Uh, Mathematics tells me that there should be some way of you know easing this, but then let's say I just remove this step. Let's just get away with it. You probably need to go from 1 to 5, or else you could do approximate the result, check the uh, error amount from actual and predicted result, uh, do a better approximation, right? And this is basically the whole idea of gradient descent. So you can go the approximation method, or else you can go the exact method, but this will always give you the exact finest exact answer. This will leave you somewhere around near to the answer, but not exactly the answer. Let's say, for example, it takes me 5 steps to get to the answer, which is somewhere around let's say 45 point so and so, right? But what this does, it takes me let's say 20 steps, but in the same amount of time, right? In 5 seconds, and again in 5 seconds, 20 steps to get to answer 45 point this much, right? Now, at this point of time, I am only 0.1 amount away from the actual result. Sometimes it's okay. I could choose to use 3 seconds and probably 10 steps to get to 46, and I'm okay with that as well. That is where I'm trading off speed and accuracy. So at the end of the day, no, you cannot. At least in my understanding, maybe someone else has a different response. But if you ask me, then my answer is that no, you cannot trade off speed accuracy. Obviously, the catch remains that if you're using, let's say, to do something like 2 plus 3 is equal to 5, right? If you're using a neural network model to answer this, you might see that it gets done in like 1 second. But if you do this on a calculator with like 20 KB of RAM, it will be faster and it will be more accurate. So yes, that is one exception. But in other ways, like when we talk about real world AI applications, accuracy and speed trade off will always be there. How do we find internships in ML on our own, as currently we are in second year? Also, do these tools enhance our chance of getting an off-campus internships? I would like to believe that these are good to have, right? I mean, if you are focused strictly on ML internships, then maybe you will not be asked about this everywhere, right? Rather, the questions will mostly revolve around your understanding of whatever ML that particular company is working with. Sometimes company might be working specifically on computer vision. Some of them might be working specifically on, let's say, fintech data. Some of them might be working exclusively with let's say NLP, maybe audio data. Like for us, audio data is used. So it totally depends on your understanding of what ML that particular company is working in, and most of the time for interns they will only test that. But then obviously again, this is very different company to company. Getting to know these tools is usually something you will do after you have started working on the solution. So in my experience, this should not be a blocker, right? If you do not know these tools at the very starting, it's okay. For interviews you should not be worried. Yes, I want to learn ML and apply it in different domains. Yes, pretty much any domain which has any kind of data. A lot of robotic systems integrating AI software into their system. Are these softwares in general compatible with what is ROS2? I do not know what is ROS2.
Maybe it should be related to operating system.
Is it Raspberry OS or something like that? I have no clue. Sorry. Yeah, we can probably take different questions. I'm seriously not aware of ROS2.
Okay, so I'm taking another question.
Yes, yes. What would be your approach to create ML project once you have your problem statement? Very interesting. Um, Let me share this screen again. Right. One, you got your problem statement, right? Step one, problem statement. Step two, I like doing this. Think about solving it without AI. Right. If you were going to solve that problem without AI, what would that solution be? Is it even possible? Uh, and only then, which parts can you replace with AI and leave out the rest? So here's the thing, right? You mostly do not require to replace an entire software with AI. There are parts which will be taken care of by AI, but there will always be a lot of parts which will not, which should not be replaced with AI. Because whenever you are using AI to replace some parts, you always have the, as I said first, the trade-off from accuracy, and the second being the speed, right? So both of these, when they are justified, only then replace the parts which really need to be replaced. Otherwise, leave them out. Uh, and then obviously, once you are done, build a rough solution. This could be the most basic AI. This could be the most basic collection of multiple AI steps, and eventually it just gets the work done. This is just a proof of concept of your solution to that particular problem statement, and then you go into optimize, right? And building a rough solution. This basically involves collecting the right data, pre-processing that particular data, and then having the right hypothesis for solving that particular problem. As in, if I do these things, then it will get solved. And finally, stringing together the most basic solution you can do, and then finally you optimize.
So this question is more or the less same, but I guess only the second part of the question is bit different.
Okay, suppose you have the problem statement and the data. Can I use AI models and algorithm without having in-depth knowledge of working maths behind them? Can you use? Yes, you can use. You can always use them, but you will get stuck on this part, right? I mean, up to here it's okay. You can just throw together a bunch of stuff, pick something from Hugging Face, put them together, make a single pipeline, run it through it. You will be okay with it. But when you come to optimization, first of all, you need to understand your data, the input, and after that, you also need to understand all the models and the different ways in which you can both maybe change your data and maybe change the model to produce a more accurate or a more speeded up resolution of your particular output that you're looking for. So yes, you can definitely build the solution, but without knowing the internals, you will not be able to optimize it. No. This is very simple, right? I mean, take an analogy of a car. Can you drive a car without knowing what all inside physics is going on? Yes, you can, right? Press the gas, turn the steering wheel. Everyone can do that. But if you are asked to repair a car, you will need to understand what's going inside.
So for the TAROS, it is robotic operating system.
Unfortunately, I've never heard of it. I'm mostly an NLP guy with some parts of CV, never into robotics. Sorry. You'll probably have to get a different speaker for that.
Yeah, even I am from NLP. Okay, so we have one more question.
I was curious about application based uses of ML for computational astronomy. Okay. For such use cases, we rather doing than courses, we should just start with projects and learn as we go. Yeah, you could think about this particular question as, let's say, uh, you are stranded on an island and you have to build yourself a shelter. Do you need to know the whole infrastructure, architecting, cement mixing, and all those things to get it done? No. You just put some rocks and sticks and leaves together. You build yourself a shelter, right? I mean, that is one way to do it. So I will suggest that whatever be that, not just computational astronomy and ML, pretty much any kind of software that you are trying to build, any kind of problem that you are trying to solve, it's okay to not be a scientist in it. It's okay to not know the entire theory of doing that. You can just get started, right? There are two ways to learn how to build, uh, you know, there are two ways to learn how to climb a mountain, right? You can either do all the theory and then you can slowly climb the mountain, or else you could ask someone to drop you from an airplane and you will still land there. You will obviously hurt a bit more, but then yes, you will get to the top of the mountain, right? And that's pretty much like it. Whatever you are trying to build, whatever you are trying to learn how to build, start building, learn along the way. Do research publications in journals and conferences boost CV for opportunities in industry? Uh, I mean, personally, see, whenever I have interviewed or seen resumes of ML engineers, uh, I have definitely valued publications in uh, journals, but there's a catch. It has to be relevant to what I do, right? What my company does. So we'll again go back to the same thing, right? If the company is working in NLP, and if your publications are in computer vision, I will probably push aside your resume. So it's more about being relevant than being published. Uh, so I will just say that it will boost, yes, but not all companies are probably working in the same domain in which you might have your publication. So I will strongly suggest that probably build projects, do a lot of exploring, and also apply to relevant companies. Then probably yes.
Yeah, so probably we'll take 4 to 5 more questions last. And yeah, meanwhile, probably you can attach the link so that I can add to the screen.
Yeah, so you can all get connected with me pretty much on all platforms you like. I have the same username everywhere, so it's totally your choice. And LinkedIn is there as well. Yes. Can you suggest some resources to learn ML with maths working behind it?
Deeplearning.ai. There.
Sorry?
Deep, deeplearning.ai. They have with math, pure math.
I mean, deep learning.ai has a great course. I think a great introductory course for uh, understanding the maths behind ML. At the same time, I think there was this blog of, I think, Jeremy Howard. Uh, Wait. Yeah, I think I like this a lot. Practical deep learning for coders. It's available at course.fast.ai, and let me put that in the private chat. I put that in the chat. So I really like this a lot. And although this is not necessarily going deep onto the math, but then these help you build a great intuition, and then you can choose to go into the math from other resources which they have mentioned. And it's always a good idea to explore these resources if you want to understand a particular technology at depth, right? So let's say, for example, NLP, and let's just go to neural net foundations. And there's a lot of mathematics that they have shown you here, mostly with programming, but then mathematics, yes. And then you can also, just go ahead and look at these resources. So something which I like a lot is practical deep learning, and you can spend some time on it. I think it has an amazing teacher, probably one of the best possible. So yes.
Yeah, for this question, I guess related to how do you get started, probably you'll have few introductory session on machine learning and deep learning during the summer analytics itself. So you'll be getting the content as well, where you'll be learning the algorithms behind ML using sklearn, and then deep learning using TensorFlow, JAX, and other library. There's one question.
Which path should you follow? I mean, why do you need to follow a path? Why do not just explore as you like? I mean, no one's stopping you from doing that, right? I would rather suggest, instead of worrying about which path to follow, you should worry about which problem to solve, right? Pick some problem, start solving it, learn along the way, pick another problem, uh, hopefully very much different from the previous problem, and start learning that as well. At the end of the day, people will not value you for having read 1000 blogs about AI. They will value you for the three great AI products that you built, right? Three great problems that you solved. So worry about solving problems instead about which path to follow. Just keep exploring and keep solving problems. Where
One answer
uh,
is you can get into hackathons.
yeah, I mean, hackathons are a great place to find out what the current industry is facing. A lot of people are building solutions around that, and at the same time, I will suggest that you probably should start following the news, at least the technical news with publications like Analytics India magazine or TechCrunch. Start following these news sites, and you will see a lot of news flowing in from different kind of companies, investments, uh, success, failures, and that is when you will start finding a lot of inspiration for the kind of problems that you might want to solve.
Cool. In the same line, I had one question from my end, just for the audience. So, how can someone leverage the tools like Perplexity in combination with Gemini or GPT? So, even GPT, right? It can do a real-time search now.
Yes. Uh, Yeah, I mean, I've not used Perplexity myself, so I'm not really sure what it does. But if you ask me how you
In
can
general,
leverage,
like any GPT or Gemini tool, because if you see, right, there were so many questions related to resources. There were how do we get started? What are the problem statement? But a simple search on GPT can generate a very well-defined solution for them. So how can someone leverage? Like, do they need to learn prompt engineering or just go out there and start doing normal Googling things?
uh, I will suggest that, first of all, start using these tools. I mean, do not worry about the prompting part. Do not worry about anything. Just start using it. Uh, start probing your, hands in discovering the boundaries of what you're working with. Right? These tools are not super powerful or omni powerful. Right? They cannot do everything for you. So once you start using, you will start understanding their limitations, and at the same time, after you have started using them, after you have started getting some kind of return, that is when you start looking into optimization, which is basically learn prompt engineering. Try to figure out which prompts will give you your expected results faster and better, and start doing that. Right? There was a time when I did spend some time around learning how to prompt better, but then eventually I realized that maybe uh, a simpler prompt which is more clear in instruction uh, is probably going to win the day for me, right? Instead of a very complex, very long prompt with a lot of general stuff in it, right? So yeah, I mean, start using them. And personally, I believe anyone who is using these tools is always having an extra tool in the toolbox. So just treat it like one, but yeah, start using them, and I think eventually you will figure out that what kind of prompt engineering do you need to learn, or whether you need to learn it at all or not.
So we'll take this one last question.
Any resources to apply AI and ML on hard real-time projects? I mean, all the tools I mentioned, you can definitely look into those tools. I think I can probably point you to another resource which will help you understand, like, how do you make decisions about applying these, and when do you apply them. So I actually have a blog written on this. I wrote this almost 2 years back. High availability ML deployments, right? This is actually a problem statement that in my company we tackle a lot. And one of the things which I've talked about is the topology of the solution that you're building, right? The system architecture. Um, Besides everything else, it shows you how to determine what topology you're going to work with, and then how to take care of all these things, right? Capacity of the network, the CPU, that CPU system or GPU system, whichever you are building, capacity within region, out of region, availability, disaster recovery time is like really important. How much time does it take for your project to come back from an impact, right? Maybe the one of the systems shut down, how quickly you can get back to responding again. It's like really important, because maybe in a Tesla driverless car, if the driving system fails, how quickly can it come back up? Does it take 5 minutes to boot? If it's taking 5 minutes to boot, there should be an alternate system as well. If it can come back within like 1 second, then maybe it's okay to not have an alternate system running, and you can dedicate all the resources to a single system. So stuff like those, yes, you can probably read around this blog. And there's also a bunch of other challenges which are like specific to AI, which I have talked about here, right? For example, quality of data, model decay, concept drift, and all those things. Um, then I've also shown you how to do load testing. So you can take a look into this, and you can see how you can check your tools, when are they going to fail, how quickly are they likely to fail, and how to measure, how to compare all these things I've talked about in this blog. Let me put the link here. I put that
Yeah,
in the YouTube chat.
cool. Uh, so where is it?
Yeah, I put that in YouTube. Also, I'm sharing it here on the private chat.
Okay. Yeah, so even I have an input on these two last questions, like where do you get the problems and the resources? So for the problems, one was what I said, hackathons, and one of the another resource will be Kaggle. I'll tell you how you can use Kaggle. Go pick any data set that you want. As I said right earlier, you need to pick a case study, you need to pick a use case, and once you pick a use case, you'll have a problem statement. For each problem statement, your first part in AIML is to get the data. and Kaggle probably is one of the largest platform where you can get the data set. Once you get the data set, right, try to see how other people are writing that code. For each data set, you will have certain notebooks. So you'll have around 100 notebooks for each data set. Try to see how other people are writing code. So this is where you will also have the resource for real-time projects. And this will also give you the problems as well. And once you understand how other people are writing code, then try to write your own new code, like after 3 to 4 attempts. So this way, you also understand how people are writing the code, on how they are optimizing it, and you also have a path of how you can write in your own way. So it's like a learning curve. See how other people are writing, and then try to innovate on your own way. So in this platform, Kaggle is probably the best. You can look at the challenges, get the problem statement, see the leaderboard, check out. You just have to filter it out. Whichever notebook has more votes, try to look into those notebooks on what kind of algorithms they're using and how they're doing the feature engineering. So once you understand that, right, probably you'll understand how you can build your own projects. Cool. Thank you again, Anubhav, for taking your time and covering so many questions and also demonstrating the real-time and soft-time problems on how we can build real-time AI application. Thank you for the time. And probably if you have any more questions, you can feel free to reach out to Anubhav and also to me. And in the coming days in the summer analytics, most of you will be learning deep learning and also machine learning, where everything will be hands-on, and then you will have hackathons so that anyone can have the experience on how you can build things. So with this, do you have any closing thoughts?
Yeah, I mean, see, real-time software. Everyone wants to build it, but eventually it turns out that not all software requires it. So wherever possible, think about not doing it real-time, as in MMT recommendations and stuff like those. Uh, and then sometimes you can do near real-time, right? I think near real-time solves most of the problems. Stuff like Amazon product recommendation, YouTube recommendations, which we see. It's okay to have them near real time. Even your fraudulent transaction detection, even that can work with near real time. So just think about not doing things real time, because doing it real time is like a whole different paradigm of software development. And while you are starting out, you can actually optimize a lot on non real time, but only when you are strictly required to do it. And requiring, like, to build real time software, you sometimes require a lot of thought and a lot of questioning around whether do I need this or do I not need this as real time in multiple components of the system, right? So yeah, try to be very sure before you even attempt building real-time software, because it's really challenging, but at the same time it will require a lot of thought work and a lot of thinking and understanding of each different component of the software, also the business requirement, right? So take some time to understand the business's requirement for real-time software.
Cool. Yeah, thank you again, and all the best for the upcoming days, and happy learning. Thank you so much again.
Thank you, everyone. Thank you, Tarun. Bye.